All right, here's some metamorphic review. So again, the one thing that you gotta know about metamorphic rocks or how to identify that they have been made is they are formed from heat and pressure. There are two types of metamorphism. The first type is regional, and this forms over a large area. There is that L in regional, think of large L regional. And this also forms when you have mountain areas, large areas. So what you're going to see is you'll have this layer of sandstone, and it may be over top of this limestone. And as it gets pushed and pushed and pushed, even more so than that when it turns into sedimentary, as it gets pushed, it gets intense pressure, which causes heat, which morphs the rock above it, so limestone eventually turns to marble. So as the pressure increases, heat increases, and you metamorphize. The second type you have is contact metamorphism. This forms when that hot igneous rock, magma, comes up and touches, typically, sedimentary rock over a small area. So you'll see my nice little prickly cactus when we look at these, and where you have the prickles, that is the spot that has been metamorphized. So we're going to start, I'm hoping, over here where you have this right here. Oh, sorry, here's sandstone, here's limestone, and here's conglomerate. These are the three layers that igneous intrusion has come up. So this is going to be considered igneous rock. So right here, and according to our reference table, you'll see that it's caused by distorting pebbles, and they may be stretched or distorted. It's metaconglomerate. And then over here with the sandstone, you'll see on page 7, I'm at the bottom of page 7, it says that it's quartz, a metamorphism of quartz sandstone. So sandstone turns into quartzite. And then underneath that, the metamorphism of limestone or dolostone gives you marble. So using page 7 and what it's made up of can help you to determine what type of metamorphic rock it is. And it's only on this line. So when you're looking at this, in the comments it says slate is made up of shale. Shall not be shiny, turns into slate. Limestone turns into marble. Conglomerate turns into metaconglomerate. And what you could do is write down right there conglomerate, and that may even help you later on. But here's the thing. We have anthracite coal. Anthracite coal is a metamorphism of bituminous coal. Now, if you add even more heat and pressure, typically near volcanoes, you can then form the mineral diamond. All right, and one thing I want to show you is the types of metamorphism right here. This says regional, heat and pressure increase with depth. So as I go down, they turn into each other. So that means slate turns into phyllite. Phyllite then gets more heat and pressure, turns into schist. Schist gets even more heat and pressure, turns into gneiss. It stops there. It doesn't go any further. That's all pushing down. Those are all regional. Whereas, this right here is contact. You get hornfels. I don't have any examples of that. And then regional or contact, you could get quartzite, marble, or metaconglomerate. And the one it doesn't show on here is anthracite coal. Just know that it is on your reference table right up here. All right, so the ones I want you to know, the underline, to start, to highlight something so that you know them. You have slate. Slate is that shiny, and you get a little bit of the shine right there. The schist is right here. It's not so shiny on the side, but once you turn it, ooh, look at that shinies. You got some shinies on the top. So it's dull on the side, shiny on the top. And then you have the gneiss get you bands, right, like that. And you can kind of see the squished, a little bit of bands there. You can see the squished crystals on this side. And then we get into our contact and possible regional. We have marble, right, like that. We have anthracite coal. This one is going to be the shiny, sharp coal. And this is the stuff that we actually put in our fire pits. It looks different than this, but this is the stuff we burn. And no, you can't burn it here. And then you have quartzite right here. This looks like wet sand almost. And then, like I said, the ugly one, you got the metaconglomerate. You can see kind of squished-ish pebbles in there, distorted. That's how you know it's metaconglomerate. All right. So which do the following morphize into? So you're using your reference table. You're using the comments to find the answers. So shall not be shiny, turns into a shiny slate. Anthracite coal. So bituminous coal goes into anthracite coal, which then forms diamonds. Sandstone. Sandstone looks like sand, red sand. It turns into like a purpley, wet-looking rock called quartzite. Limestone. It usually is like a whitish or gray marble. Think of like the gray limestone we've seen in class in the boxes. That turns into gray limestone. And then you have conglomerate, turns into the big mouthful of metaconglomerate, and I think it's like the ugliest one that we have. All right, so now that we're done with that, we're going to start with slate. Slate goes into phyllite, which I do not have, which then pushes into my schist, and then it goes into my banding with the gneiss. So slate, phyllite, schist, and then gneiss. So name a rock formed by regional morphism. So you're going to look for one that says regional only. Sorry, I've got some there and one right there. And then you're going to look for the term banding. And if you look right there, it says banding. Follow it across, and you have gneiss, which is the only mineral that slate has in it. So looking at this, looking at slate, I'm going to follow it across to the composition. There's a bar in composition, and if you follow that down, it says that it's mica. Why does marble bubble with acid? So marble is made up of limestone or dolostone, and on page 16 of our reference table, you have, limestone and dolostone. I skipped one. I come up here. Limestone is made out of calcite. Dolostone is also made out of dolomite. And then if I go back to page 16, calcite bubbles with acid. Dolomite bubbles with acid. So that's why marble bubbles with acid. You don't want to get acid on your marble sidewalks. What can I use? What do I have that I can use to determine how metamorphic rocks turns into magma or sediments? What could I use? Could it be our reference table, page 6, the rock cycle? If you look at metamorphic rocks, it melts to turn into magma, or it weather and erodes to turn into sediments, which then turns into sedimentary rocks. All right. So that is it for the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.